children of class 8. So we will be continuing the same chapter that we were doing in class, that is chapter 2, physical change and chemical change. So in class we have already done physical change. Let me revise it once. In a physical change, no new substance is formed. Physical change is a temporary change. Physical change is irreversible change, and in physical change, net energy is neither evolved nor absorbed. Okay? So in a physical change, that means dissolving, melting, freezing, evaporation, condensation, then sublimation, all these are physical changes. Because of these processes, no new substance is formed, and the substances will not lose their properties. That means mixture is a physical change. Making a mixture is a physical change. Now, today, we'll be doing another part of the change, that is chemical change. So, what happens in a chemical change? In a chemical change, the original substance. In a chemical change, the original substance gives rise to one or more new substances with entirely different compositions and properties compared to those of the original substance. That means when you combine one or more substances when a substance gives rise to two or more new substances with entirely different properties, okay, then its constituent or then its original substances, we can say the change is a chemical change. We can say the change is a chemical change. So, conversion. Example, conversion of uncooked rice to cooked rice. What do you think? Conversion of uncooked rice to cooked rice. Is it a physical change or a chemical change? What do you think? Yes. What do you think? Yeah? Is it a physical change or a chemical change? Conversion of uncooked rice to cooked rice. Now, how to know whether this change is a physical change or a chemical change? Let me tell you, in a chemical change, taste changes. In a chemical change, taste changes. In a physical change, no taste is changed. No taste is changed in a physical change. So, in a chemical change, taste changes. Whenever you are dissolving sugar in water, you will get sugar solution. So, what is the taste of sugar solution? It is sweet. And what is the taste of sugar when you taste separately? Again, it is sweet. That means in a physical change, taste remains same. In a physical change, taste remains same. But in a chemical change, taste changes. For example, if you taste uncooked rice, the taste will be different. If you taste cooked rice, the taste is different. Again, in order to make it clear, taste of sugar is sweet, but sugar to sugar charcoal. Sugar to sugar charcoal. When you are converting sugar to sugar charcoal, that means when you are burning sugar. The burnt sugar will be black in color. This sugar is white in color. This sugar will be black in color. This charcoal is black in color. The color is also changing and the taste also. Sugar is sweet to is beta to test. Beta to test. So why this is happening? Because chemical change is taking place. What is taking place? Chemical change is taking place. So what we have understood so far? So far what we have understood? So with the example we came to know that in a chemical change, test of a substance changes. For example, sugar is sweet and sugar charcoal is bitter. So what is converting this sugar to sugar charcoal? Burning. That means burning is a chemical change. Burning is a chemical change. And what was changing sugar to sugar solution? It was dissolving. So dissolving is a physical change. Now, mango, raw mango. Okay, raw mango, unripened mango is sour to taste. But ripened mango, ripe mango is sweet to taste. That means again here the taste is changing. So new substance is formed. Entirely different properties. Why the properties are different? Because the taste is also different. So why the taste is different? Because the composition is totally changed. So entirely different composition. Composition is also changed. Now let me tell you what is the composition. See here. Sugar to sugar charcoal. Now what is the thing is that we cannot see molecular change. We cannot see the composition change. We cannot see the change in molecular composition. That's why we have to think of the changes which we can observe. So what we can observe is sugar is white in color, sugar charcoal is black in color. Another thing what we can feel is the taste. Taste is sweet, taste is bitter. What really is happening in the molecular level is sugar. The formula for sugar is C12H22O11. But when you burn it, you will get carbon only. Sugar charcoal is carbon only, and some portion of water will go. Some portion of water vapor will go. So this molecule will convert to carbon and water vapor. Carbon and water vapor. Can you see the molecular composition? That means molecule is also changing. Molecular formula is also changing. Molecular formula is also changing. Then this is what happens in a chemical change. So if I tell you respiration, is respiration a chemical change or a physical change? In respiration, what happens? Glucose converts to carbon dioxide and water vapor. Means molecules are totally changed. Molecules are totally changed means it is a chemical change. It is a chemical change. Let me explain this with another example, that is hydrogen plus oxygen gives water. Now hydrogen is a gas which can burn. Oxygen is a gas. This is a gas. This is also gas. But this is a liquid. So state is changing. Which can burn, which supports or helps in burning, which helps in burning. Neither burns nor helps in burning. Neither burns nor helps in burning. This is what happens in a chemical change. In a chemical change, entirely new substance with different composition and properties will form. Composition: hydrogen is H2, oxygen is O2, your molecule of water is H2. So composition is changing, and properties, since the composition is changing, properties are also changing. Now let's see what happens in a chemical change in detail. New substances. Substance or substances are formed. In a chemical change, what happens? New substance or substances are formed. Okay? I said hydrogen combines with oxygen to give water. That is the example. Or unripe mango converts to ripe mango. That is also example. Sugar converts to sugar charcoal. That is also an example. So new substances are formed. Number 2, the change is irreversible. Irreversible. The change is irreversible. Irreversible means on reversing the conditions. On reversing the conditions, you will not get the original substance back. On reversing the conditions, you will not get the original substance back. That means it is irreversible. Once you mix lemon and milk, you will get curd. But you won't get milk and lemon back. That is irreversible change, and that is a chemical change. Once you burn a paper, you will get ash, heat and light. But on reversing the condition, that means once a paper is burnt, you will not get back the paper again. So that is a chemical change. But if you tear the paper, new substance is not formed. So that is a chemical, physical change. So in a chemical change, on reversing the conditions, okay, you will not get the substance, you will not get the original substance back. That is one of the property of a chemical change. So the change is irreversible. Then number 3, energy changes in a chemical change. Energy changes in a chemical change. Energy, that means either energy is absorbed or energy is released. So in respiration, energy is given out. In respiration, energy is given out. In photosynthesis, energy is absorbed. So because of respiration, our body is maintained. Heat of our body is maintained because of respiration. Because as a result of respiration, glucose changes. Glucose converts to carbon dioxide, water vapor, and energy. And in photosynthesis, solar energy is absorbed. So in photosynthesis, energy is absorbed. In respiration, energy is given out. That means both of these, photosynthesis and respiration, Photosynthesis and respiration both are chemical change because energy is changing. While dissolving sugar in water, net energy is not changed. Net energy is not changed. So these are some of the things that happens in a chemical change. Now let me tell you the example. You must be thinking, oh, that means the change in which new substance is formed is a chemical change, and the change in which no new substance is formed is a physical change. But can there be any change in which both takes place, physical change as well as chemical change? That means, is there any change in which means new substance is also formed? That means it is a chemical change, and it is a physical change as well. That means, can you give example in which chemical change and physical change takes place simultaneously? That means at the same time the change is physical and chemical also. Can you give one example? That is burning of candle. So burning of candle is a physical change as well as chemical change. Burning of candle is a physical change as well as chemical change. If someone asks you, give an example, okay, where physical change and chemical change both takes place at the same time, then you can say burning of candle. So whenever you are burning candle, then melting of candle. When you burn candle, some portion of the candle melts. When you burn candle, some candle will melt, and melting of candle is a physical change. Melting of candle is a physical change. Then burning of candle to give heat, light, carbon dioxide is a chemical change. That means some portion melts, and that is a physical change, and some portion burns to give you heat, light, carbon dioxide, wax vapor is formed. So that becomes chemical change. So why melting of candle is a physical change? Because once you can see the state is changing, solid is converting to liquid, and again on cooling the liquid is condensing. Okay, the liquid is freezing. The liquid is freezing to solid. So hence melting of candle is a physical change. So this is the example, which is the example for both physical and chemical change taking place at the same time. This much for today. Thank you.